Alright, I'll try and go over this and hope this helps you. So the Lewis dot structures, you know, these are just based on the numbers of valence electrons. One more time, if we see the periodic table, these have 1 valence, 2 valence, 3, 4, 5, 6, 7, and 8 valence electrons. Helium, of course, would only have 2. And then we put our dots 1, 2, 3, 4, 5, 6, 7, 8. So there's a couple ones. I think those are easy enough. And then down here, we just remind you, you draw the Lewis dot structure. The number of unpaired electrons tends to be the number of bonds they make. So 4 single electrons, 4 bonds. There aren't any lone pairs here. In this one, we tend to make 2 bonds, one there, and then there are 2 lone pairs here. So I think that should make sense. When we move to this thing of bond geometry and bonding, a single bond would share 2 electrons, double bond would share 4, triple bond would share 6. How does the amount of ionic character influence the type of covalent bond? Well, if you look at this, and I don't expect you to see it so close, but if this is just differences in electronegativities, when you subtract one electronegativity from another, say in this case 1.5, this, according to this chart, it would show an ionic character of about 43%. As the number gets bigger, over here at 3.2, it's 92% ionic character. When there's hardly any difference, electronegativity are the same, then there's 1 or 2% ionic character. Now it says define what a chemical bond is. Well, a chemical bond is just a mutual attraction between 2 atoms. I haven't stressed some things, but let me just put this here. A bond, when we say a chemical bond, what we mean is an intramolecular bond, meaning it's a bond that's within a molecule. It's the glue that holds the atoms together within the molecule. Now there's 2 types of bonds, 2 broad types of bonds. There are covalent bonds and there are ionic bonds. The difference, we would say, is a covalent bond will share the electrons. Ionic bonds, they transfer the electrons so that one of the atoms becomes a positive ion, the other atom then will become a negative ion. Now you have positive and negatives, they will attract. And when they do that, we make what are called formula units. And those small formula units would then combine to make a crystal lattice. Alright, so it'd just be a collection of these positive negative ions. In the covalent category, then depending on how they share the electrons, if they share them equally, we call that a nonpolar bond or nonpolar covalent, or a polar covalent if they're shared unequally. So hopefully that helps on that. As a result of those differences, we'll see some changing characteristics. So, for example, ionic compounds have very high melting points. It's hard to break apart those ions, plus minus attractions, so they have a high melting point. Whereas a polar covalent tends to have a lower melting point, and then a nonpolar covalent has a very low melting point in general. Do they share electrons? No, not really. They transfer electrons, but we could say they share them so unequally that they result in plus minus particles. Polar covalent, yes, they share them unequally, and nonpolar, they share them equally. Do bonds form in ions? Well, with ionic compounds, they do. And we would say there aren't ions in the covalent compounds. Generally, we'd say ionic compounds are soluble in water, polar compounds are usually soluble in water, and nonpolar compounds tend to be very low in terms of their solubility. And then just a broad brush generalization here, we would say at room temperature, ionic compounds almost universally will be a solid. A polar covalent would probably be a liquid, could be a gas, but in general we'd say probably liquid, and then nonpolar more than likely would be gases. Lastly, on this sheet, VSEPR theory just stands for valence shell electron pair repulsion, because those pairs of electrons want to get as far away from each other as possible. Here's just an example. So we'd say this is very unstable. We'd call that our free radical. This would be a free radical, but they would combine, become more energetically stable, and then we'd redraw that and we'd say now we have a more stable compound, hydrogen and chlorine combined in a covalent bond. When we compare the electronegativities, chlorine would be 3.16, hydrogen would be 2.10. Do the math, subtract the smaller from the bigger, and we'd get 1.06 would be the difference, so that would be a quite polar bond. Ionic bonds almost always have metals and nonmetals, so we haven't done too much with metals in this particular unit, but can you see how calcium, we would say, wouldn't share the electron. Usually it would just get transferred to another one, and what you end up with is an anion from the chlorine, a cation from the calcium, and an anion from chlorine.